So now we're going to put everything we've learned together into one example. And we've seen this data set before. This is the percent of students that receive free reduced lunch and the percent passing a math test for a bunch of different schools in Sandusky, Ohio. All right, so we have the graph over here, and you'll notice the graph doesn't have the equation given. Right, so we'll have to find it ourselves using StatCrunch. So that's the first thing it wants, is the line of best fit. Okay, so to find the line of best fit, we'll have to use the same StatCrunch path we use for everything in this chapter. So that'll be stat, regression, simple linear. Right, that's our StatCrunch path. All right, so let's go do it. Now I have this data set already in our sheet full of data sets. It's right here. But we could also just grab it. I've already grabbed it. It's right there. So now I'm going to go to stat regression simple linear. Remember that the x is the one on the left and the y is the one on the right. That's the way I will always set these up. And I will say compute. And remember, we don't need the rest of it. We just need this beginning at the top. Okay, so remember this is the response variable, the y. This is the x. Now it is a little confusing here because when it's writing the equation, it's writing it with all of those variables. So that right there is the y equals this number minus this number, and then the rest of this is the x. And that's a little confusing. So what you can do is you can actually go here and change the letters. So I can say, look, let's make this x and let's make this y. So now they stay x and y. So if I run this again, or if I click refresh, options refresh, now it actually looks more like an equation, right? That's more what we want. So if you don't like the words, you can do it with the words. I do it with the words all the time. But if you don't like them, you can switch the variable column names to x and y and go from there. So I see the equation right here. It's y hat equals 69.108 minus 0.283x, right? 283 because the number after the 2 is a 5, and so we would round it up. Okay, so let's make some notes to ourselves. This is x, this is y, right? And so then when we go here, we write the equation. It has to be in a form that is y equals, well, y hat equals a number minus a number x, or a number plus a number x, something like that. There should be two numbers and an x and a y hat when you write this equation. Now, if you're skilled at algebra class, if you're more comfortable with the algebra way of writing it, it's negative 0.283, that's your slope, x plus 69.108. So whichever way you want to write it, it's fine. I'm going to stick with the statistics way. That's the way that StatCrunch gives it to us. So that's what we're going to be more familiar with. Okay, so let's look at our first question, which is the slope portion. Actually, I'm going to rewrite this piece over here so I have room to label. So give me 1 second. There, I just decided to move that. And I put plus or minus in there because some equations it's plus, some equations it's minus. It depends. This one's a minus one because it's a negative relationship. All right, now what's the slope? Well, the slope is always the number that's with the x, whichever way you write it. So it's right there, it's that one. Okay, so now what does that mean? So let's take the script for interpreting slope, which is back several pages. If the x increases by 1 unit, then the y is expected to increase or decrease by approximately this many units. All right, so I'm going to write that out. Okay, I'm filling out the script. So if blank, that'll be our x, increases by 1 blank, then y is expected to, this will be a decrease because this word is negative. So we're going to put decrease on this one by blah units. Okay, so let's label everything. X. X was this percent of students on free reduced lunch, and it really pays to label this. Okay, so if the percent of of students on free reduced lunch. Students with free reduced lunch. Oops, if I can fit it all in. There we go. So that's the x, right? That's what I'm explaining, right? So that's x. Increases by 1. Now notice x is in words. It's not a number. So if x increases, if the percentage of students on free reduced lunch increases by 1 unit, well, what was the unit? Well, it was kind of percent, right? So that's the unit, if you will. A lot of times these will have units like feet or whatever, but this case it'll just be percent. So that's the x unit, if you will. Then, all right, now I have to write about the y. So the y was the other variable, which is over here, and it really pays to kind of write this down. It's also up here in the table if you have a table, but it's the percent of students passing the math test. So percent passing math test. This is not my most fine, it's not my finest English hour, let's put it that way, but that's the y variable, right? And this is the x variable, is expected to decrease by, what was the slope? Well, the slope was 0.283. And you don't have to put negative. And the reason you don't put negative is because this word right here. So this word is positive if it's increase or negative if it's decrease. And since we had a negative slope, we chose decrease. And then it'd be by 0.283. And again, my unit, if for lack of a better term, is percent. So that's my y unit on this case. They will not always be percents, and they will not always be the same thing for both x and y. It just worked out that way. All right, so we've used the script to help us. Now, interpret the y-intercept in the context of the situation. Does it make sense? Is it outside the scope of the model? Okay, well that's a bunch of questions actually. So let's look at interpreting the y-intercept, which I would argue does not make sense. And I think maybe we should just say it that way. The y-intercept would be if a school had no students, 0 students on free reduced lunch, right? So think of what the y-intercept is. So the slope was negative 0.283, right? So that was the slope. The y-intercept is a point. It's 0, 69.108. But the 0 is problematic, right? Because the 0 would mean that x is 0. And that's impossible, right? It's impossible for a school to have no students, 0 students receiving free reduced lunch. Right? And it's important that you understand that that's the x. And you have to tie it back to what the x variable was, which was the percent of students on free reduced lunch. That's the part that makes no sense. You would never have a school have nobody at all on free reduced lunch. Now, is this outside of the scope of the model? Yes, right? So outside the scope of the model, for sure, because there were no schools in our data set that were remotely close to x equals 0. So I've answered the first part, right? I interpreted insofar as it does not make sense. And now for the second part, for outside the scope. We would say yes, because no school in our data set was close to, well, x equals 0, 0% on free reduced lunch, right? So I'm kind of mentioning what it is, right? Nobody was close to that. And it's usually the x in particular that makes it outside the scope of the model. The y, 69, we had some numbers in the high 60s, so that's not really the problem. The problem is the x, right? You can't have x be 0 and have it make any sense. And you could if we had a lot of schools that were much closer to zero. But the closest school we have is 15. 15% of your classes or students needing to be on free reduced lunch is a very different world from zero.